Yeah, so that's recording now.
This call is now being recorded.
So today's session, we're going to be covering all of ratio and trigonometry. So some of you may have seen it, some of you may not have seen it. The class will benefit both the foundation students and the higher students because the higher students need to know all of this as well as extra, which will be covered tomorrow in the higher class. So keep yourself on mute. Any question, put them in the chat. The chat's open, so I should be able to answer them all. So I'm just going to get started. So ratio, what is ratio? So ratio is just a way of showing how one thing is compared to another. So how one thing is compared to another. So for example, if I give a real life example, I have 3 to 2 red counters, blue counters. That sign here just reads as 2. So you would say 3 to 2. So what that basically means is for every 3 red counters, we have 2 blue counters. For every 3 red, we have 2 blue counters. That's the basics of ratio, just comparing one thing to another, and the colon sign just means 2. So moving on, let's understand what this sort of means. So if I do a bit of a drawing, so imagine I've got a bag, and in the bag I've got 2 blue counters and 3 red. So there's my bag. In the bag I've got 3 red counters, 2 blue counters. Altogether, I have 3 plus 2, which is 5. So altogether I've got 5 counters, but out of that 5, 3 are red, 2 are blue. So that's the basics of what a ratio is, just comparing something and think of it as a whole. If you add them both up, that's the total amount, but in that total amount, it is telling you how much of each you have. Okay, so there's a couple of things we can do with ratios. We can write ratios as fractions, we can simplify ratios, and we can also scale up ratios. So if I just go through each of them, so writing ratios as fractions. So the first thing we can do is write them as fractions. So how ratios are written as fractions is, so we can see the fraction has if I just a numerator and a denominator. The numerator is the amount you have, and the denominator is the total amount. So in this case, we can say the total amount we have is 5. So I'm gonna put them as a ratio under 5 because that's the total amount, and we can see there's 3 red counters and 2 blue counters, and the denominator is just a total amount. So each time you write a ratio as fraction, just make sure your denominator is the total amount of ratio that you have, and the numerator is what each you have, each of them, sorry. Okay, so that's writing ratios as fractions. Simplifying ratios. So number 2, the second thing you can do is simplifying ratios. So simplifying ratios just means you need to divide your ratio by a common denominator. Divide the ratio by a common factor. So let's do, so using this example 3 to 2 again. So my ratio is 3 to 2. So if I'm going to simplify just means keep dividing it until you can't divide it anymore. So I'm gonna divide both sides by 2. So 3 divided by 2 is just 1.5, and 2 divided by 2 is just 1. So I've simplified my ratio by dividing it by 2. Sometimes they'll tell you in the exam question is divide them by 2, sometimes they won't. It just depends on what the question says. But if they haven't given you like what to divide it by, just assume you're simplifying it until you can't simplify it anymore. So simplifying is you're dividing both sides by 2, not both sides, but both sides by the same number. That's what simplifying is. And this sort of leads down to direct proportion as well. Direct proportion links to simplifying ratio is sort of the same thing. You divide both sides by the same amount. Simplifying ratios. And the third thing you can do is scaling up ratios. So scaling up ratios just means you are timesing both sides by the same common factor. Timesing ratio, both sides by the same, or you could say common factor. So again, using the same example, my ratio is 3 to 2. I'm going to scale up, so I'm going to multiply both sides by 2. 3 times 2 is just 6. 2 times 2 is just 4. Therefore, my answer is 6 to 4. I've scaled it up using the ratio given. So scaling up ratios is used in best by questions and proportion ingredients questions, which we will be doing exam questions on. So we've covered the basics of ratio, what ratio is in simple terms, how to write ratios as fractions, simplifying and scaling up ratios. So I'm just going to move on to the exam question before we move on to the next topic. Exam questions just here. So let's start on these. So all of these will be sent out to you as well. So all the notes I make will be sent out as well, the worked out examples. So if we do question 1, question 1 says, write down the ratio of 220 kilograms to 5 kilograms. Give your answer in its simplest form. This is a very typical exam question that comes up in the foundation and the higher papers in the first couple of questions. Write down the ratio and simplify it. So we know the ratio is given to us 220 to 5 kg. So 220 to 5. So I've written my ratio, and this question is 2 marks. So you will get 1 mark for just writing this, even if you don't simplify it down. So I'm going to find a common factor of both of them. I know both of them will divide by 5. So I'm going to divide this side by 5, and I'm going to divide this side by 5. 5 divided by 5 is just 1. It's going to be left as 1 kg. 220 divided by 5. So if you have a calculator, if it's in the calculator paper, you can just use your calculator. However, if it's not in your calculator paper, then you need to show you're working out. So I'm just going to quickly do the bus stop method. 5 cannot go into 2, therefore I'm going to write 0 and carry the 2 over. 5 goes into 22 4 times, and the remainder is 2 because 5 times 4 is 20. 20 plus 2 is 22, so the remainder is 2. 5 goes into 20 4 times. There's no extra remainders, therefore 220 divided by 5 is just 44 kg. And therefore, I've written it in my simplest term. Make sure you write your answer on the line. So my simplified ratio is just going to be 44 to 1. That's how you do it. So make sure you're working out is trying to get the full 2 marks. So I'll move on to the next question. Second question says, write the ratio 32 to 24 in its simplest form. So here we need to find a common factor which will divide 32 and 24. I'm going to divide both of them by 4 first. So 32 to 24. Actually, I'll just divide by 2 first because I know 2 is the easiest one to do. If you're rushing for time and you can't think, always, if they're both even numbers, the easiest thing to do is divide them by 2. So I'm going to divide both sides by 2. 32 divided by 2 is just 16. 24 divided by 2 is just 12. And I can see that they're still both even numbers, so I can simplify even more. So again, I'm going to divide both sides by 2. 16 divided by 2 is 8. 12 divided by 2 is 6. I think I can divide it one more time because they're still even numbers. So I'm going to divide them again by 2. 8 divided by 2 is just 4. 6 divided by 2 is just 3. And I can see that it's not going to simplify even more. So I've got it to its simplest form. So my simplified ratio is just 4 to 3. So by simplifying, I mean, you can keep simplifying further down until you get to your numbers that cannot be simplified even more. So the answer is just 4 to 3. Part B says 1/9 of people in a class are left-handed. Write the ratio of left-handed people to right-handed people. Now they've given us the fraction which are left-handed. So if you just look at the fraction again, 1/9, that tells us how many are left-handed. So I'm just going to put LH for left-handed, and the denominator, if when I talked previously, the denominator tells us the total amount. So I know altogether there's nine people that which are either left-handed or right-handed, and out of those 9 people, only one is left-handed. So if I do a bit of basic maths, 9, which is the total amount, take away the one which is the left-handed, that gives us 8 people which are right-handed. And now I can write down the ratio. The left-handed people is just 1, the right-handed people is just 8. So 1 to 8, left hand and right hand. Typically, at the top of each ratio, we just write down what each of them means. So if you want to make the examiner aware that the 1 is left-handed, the 8 is right-handed, so that would give you the 1 mark. And again, simplify it if you need to simplify it. If not, then if it can't be simplified, then just leave your answer like that. Moving on to question 3. Now, this is a very common question, writing it in the form 1 to n. So write the ratio 20 to 30 in the form 1 to n. So the clue is given in the answer 1 to n. So if I just write down 12 to 30, I need to get into the form 1 to n. So I know this needs to go simplify down to 1. So it's given it. So always put them under each other so you can see either the left-hand side or the right-hand side, which one you're dividing to get to 1. So I need to see what can I divide 12 by to get to 1. So obviously 12 divided by 12 is just 1. So whatever you do on the left-hand side, you have to do it on the other side. So I'm going to do 30 divided by 12. Now, if I just do my calculator, use my calculator, 30 divided by 12 is just 2.5. So n is essentially 2.5. That's we found n. So we've got 1 and the n is just 2.5. Okay. So just remember when you're doing these kind of questions, look for where n is. So that will give you a clue of which one you're converting. Moving on. So writing ratios, this is the writing ratios of fractions questions. So ratio questions are typically the most worded questions. So it's always better to understand what the question is saying and highlight what's actually asking, the question is asking for, so you don't misinterpret the question. So in a bag, there are blue sweets and red sweets. The ratio of blue sweets to red sweets is 2 to 7. What fraction of the sweets are red? So first of all, I'm going to write down what the ratio is so I can see it clearly. So 2 to 7, that's my ratio. And it's the ratio of blue to red. So this is going to be blue and this is going to be red. So I've written it down. I can see clearly which is my ratio. Right, it says what fraction of the sweets are red? So we need to convert the ratio into fractions. So we need to first work out what's the total amount. Total amount is just my two ratios added up. So 2 plus 7, which is 9. Now, going back to the fractions, that's my ratio and that's my total. So I'm going to write them both under 9, which is the total. And the ratio of blue is 2. So 2 out of the 9 are blue and 7 out of the 9 are red. And you will know your answer is right because these two should add up to the total. So it's always better to double check your answers that they do add up to the total amount which is there. It says, what fraction of the sweets are red? So the red is just 7 out of 9. And I can't simplify that, so I'm not going to simplify it. So next question. Number 5. So this is sharing, not sharing ratio. So it's a ratio with 3 ratios in it involved. So in the bag, there are blue sweets, red sweets, and green sweets. The ratio of blue sweets, the ratio of blue sweets to red sweets to green sweets is 2 to 4 to 5. What fraction of the sweets are red? So same thing, but it's with 3 ratios involved. So I'm going to write down my ratios first. 2 to 4 to 5. Blue, so 2 is going to be blue because it's given in the order. The order they've written it in is the order the ratio is in. Blue to red to green. It says what fraction of the sweets are red? So I am trying to work out the fraction of red. So first of all, again, writing fraction, you need to work out the total. Total is going to be 2 plus 4 plus 5. 2 plus 4 plus 5 is 9, 10, 11. So we've got 11 in total. That's the total amount of ratio. And then the red is just going to be 4 divided by the 11. The green is going to be 5 divided by the 11, and the blue is going to be 2 divided by the 11. There you go. Right, moving on. So if you have any questions, do add them in the chat. But if you're okay, then that's fine. I'll just move on. So in a bag, there are only red sweets and yellow sweets. 3/5 of the sweets are red. Write down the ratio of red sweets to yellow sweets. So this time they've given us the fraction, but we need to work backwards and work out the ratio. So there are only red sweets and yellow sweets. 3/5 of sweets are red. So I'm going to write it down in ratio form. So 3/5 are going to be red. And I can see the total is 5. So the amount of yellow sweets is just going to be the total, which is 5. Take away the amount which is red, which is 3, which is just 2. Therefore, the amount of yellow sweets is 2 out of the 5. But it says write down the ratio. It's not said write down the fraction. So if you're writing it in ratio form, it's just going to be 3 to 2. We don't write the fraction part. Therefore, there's 3 red and 2 yellow. So this is why it's important to look at what the question is asking you. So you don't want to end up writing the fraction form and losing out on a mark because it is 2 marked question, 2 marks that you can get. So moving on, sharing ratio. So this is more like the grade 4 stuff. Sharing ratio is the big topic. Lots of questions come up in these. So we'll go through the steps of how you're supposed to share the ratios. So Will and Ollie share £80 in the ratio 3 to 2. Work out how much each of them get. So Will and Ollie get 3 to 2. And the sharing was given to £80. What was the answer for number 6? The answer for number 6 was 3 to 2. Let me just write that up clearly. 3 to 2, that was the answer. Because they've asked us to give it in ratio form, not fraction form. Okay, so moving on. Will and Ollie share £80 in the ratio 3 to 2. Work out how much each of them get. So what this question is basically saying, they've given you how much they're going to be getting in a ratio form. So you need to share £80 in that ratio. So if we take a look at it, we know Will is going to get 3 parts. So this is where parts gets introduced. So a ratio can also be known as parts, or 3 sections or 3 parts. So Will is going to get 3 parts of that £80, and Ollie is going to get only 2 parts of that £80. So we need to share them up. So what we're going to first do is we're going to add the parts up together. So step 1 is always, when you're sharing ratios, is add the parts or add the ratios. So 3 plus 2 is 5. So altogether, there's 5 parts or there's 5 ratios altogether. So then the next step I'm going to do is I'm going to divide the total amount by the number of parts so we can see what each part is going to be worth. So £80 divided by the 5 parts. 80 divided by 5 is just £16. So what that essentially saying is each part is just 16. So that's 16, that's 16, that's 16, that's 16, and that's 16. Now we can just add up the total amount. We can add what 3 parts is going to be equal to. We can add what 2 parts are going to be equal to. Work out how much each of them get. So Will is going to get 16 times by 3 parts. 16 times 3 is just £48. And Ollie is going to get the £16, which is 1 part, times by how many parts he's got? He's got 2 parts. 16 times 2 is just £32. So that's how much each of them they get. So now we've shared the £80 between both of them in their parts. If you want to double check your answer, the total of these two should be £80. So you know you've shared the total amount. So 8 plus 2 is just 10. 4 plus 3 plus 1 is just 8. So we can see the answers right. So Will gets £48 and Ollie only gets £32, which makes sense because Will gets more parts. So hopefully that makes sense. Right, let's move on to the next question. So Al, Tom, and Joe share €3,000. The ratio of the amount Al gets, the amount Tom gets, is in the ratio of 5:4. Joe gets 1.5 times the amount Tom gets. Work out the amount of money that Tom gets. So let me just highlight what the question is said so we can understand. So they're sharing €3,000. The ratio of the amount Al gets, the amount Tom gets, is the ratio of 5:4. So they've only given the ratio of Al and Tom. They're not given the ratio of Joe. But the next part of the question says Joe gets 1.5 times the amount Tom gets. So first we need to work out what the ratio of Joe is going to be. So the question says Joe gets 1.5 times the amount Tom gets. So that's Al and that's Tom. So if Tom gets only 4 parts, so Joe gets 1.5 times what Tom gets. So if I just times that by 1.5 times what Tom's part is, 1.5 times 4 is just 6. So we know Joe is going to get 6 parts. So now we've got the ratio. We can write the ratio down. 5 to 4 to 6. So 5 is Al, 4 is Tom, and Joe gets 6 parts. That's the only extra step that the question said. They haven't given you the ratio of Joe. You need to work out what the ratio is given using what they've said to you. So again, they're sharing €3,000. So we can see Al gets 5 parts. 1, 2, 3, 4, 5. Tom gets 4. And Joe gets 6. So you can visually see how many parts they get. So next step is add up all the parts. The first step is 5 plus 4 plus 6 is just 15. So altogether there's 15 parts. So all of these are 15 altogether. So then we can do the total amount which they are sharing, which is €3,000. Divide that by the total amount of parts, which is 15 parts. So if you do 3,000 divided by 15, each part is worth €200. So this is 200, this is 200, this is 200. So you get the gist of it. Each part is 200. So the question says, work out the amount of money Tom gets. So Tom is, I'll just circle it. Tom is here. So we can see Tom gets 4 parts and each part is worth 200. So we're going to just do 4 parts. Times that by the 200, which is just €800. 4 times 2 is 8, and then add 2 zeros, 800. So you can see Tom gets 800. If they ask about Joe, Joe is just going to be 200 times by 6 parts. If they ask about Al, 200 times 5. So it's the same sort of concept. First, do your total amount which they've given to you in the question divided by the total number of parts. So you can see what one part is worth, and then you times it by each amount of parts that each person has in the ratio. So if there's no question, then I will move on. I think there's one more question. Yeah. So this is also a very common question. So it's sort of the same sharing ratios, but the question's a little bit different. They've not told you the total amount that each of them get. And kids tend to get quite confused because they're not reading the question properly. They just assume, okay, they're given 70, they sort of rush the question, but it's very important to read what the question is also asking for you. So the question says, Carly and James share some money in the ratio of 5-3. So they're given us the ratio, that's one thing. It says Carly gets £70 more than James. So the only thing that we know is Carly is getting £70 more. We don't know the amount, the total amount they've shared, what they started off with. Work out how much money James gets. So first of all, I'm going to write down the ratio. There's Carly and there's James. If I just draw the parts out, so we can see 5-3. Then it says Carly gets £70 more than James. So it's 3. So we only know she gets £70 more. We don't know how much the total amount she's got. We don't know how much James has got. So if you can see from the parts, they both get 3 parts each. So we can see they both get 3 parts each. But the only extra that Carly has is 2 parts. So she's got 2 more parts extra. And it says she gets £70 more. So essentially, them 2 parts should be equal to £70. These 2, which are the extra parts, should equal to £70. Because that's what the question says. She gets £70 more. So if we know the £70 can be shared by the 2 extra parts, so £70 divided by 2 is just 35. Therefore, we know one part is 35. So we can assume this is 35, this is 35, this is 35, this is 35. All of them are 35. From finding out the extra parts that Carly has, and which correlates with the question that she gets £70 more. So now we can say how much money does James get? James gets £35 times by how many parts has he got? 3. £35 times 3, which is just £105. That's how much he gets in total. If the question asks you find the total amount, you're going to do 35 times by 1, 2, 3, 4, 5 parts. 35 times 5, it's just 175. So Carly gets £175 altogether, and James gets £105. So a bit of a confusing question, but it is the more grade 4, grade 5. So we'll do one more question on this, and hopefully should be okay. So just always remember the amount the person gets more always equates to the amount of more parts that they have. So using the more parts that they have, divide it to find out what one part is, and then you can assume all of them parts are the same amount. So moving on to question 10. Jerry and Mick share some ratio in the ratio 2-3. Mick gets £900. Work out how much money Jerry gets. So let's just highlight. So Jerry and Mick share the ratio in 2-3. Mick gets £900. We know exactly how much Mick gets. So let's write down the ratio. 2-3. Jerry gets 2 parts and Mick gets 3 parts. So I'm just going to draw it out. There you go. It says Mick gets £900. So all of what Mick gets is £900. So those 3 parts should be equal to £900. So if you want to find out what one part is, you always divide. So I'm going to do £900 divided by the 3 parts, which should give me what one part is. 900 divided by 3 is just 300. So 1 part is 300. So that's 300, that's 300, that's 300, that's 300, and that's also 300. So now we worked out what 1 part is. Work out the amount of money Jerry gets. So we can see Jerry gets £300 times by 2 parts. So altogether, Jerry gets £600. So does that make sense? Is that okay? Right. And that's all of ratio, the basics of ratio sharing, dividing, scaling, and fractions done. So we're going to move on to the next part of ratio, which is direct proportion and inverse proportion. Because the class is only till 2:30, so I am wary of time because we've got trigonometry to cover as well. So direct and inverse proportion. So like I said here, direct proportion is sort of like simplifying ratios, and inverse proportion is the opposite. So I'll go through what each of them means. Oh. So direct proportion is sort of in the question. Direct just means whatever you do on one side, you do it on the same side. So divide on one side, you divide on the other side. So it's same actions on both sides. So if I give you an example, um, just example, 3 apples cost me £1.30. So if 3 apples cost £1.30, um, how much will 5 apples cost? So you want to find the cost of 5 apples. So we can't jump from 3 to 5 without doing some complicated math. So the easiest way to do it is you divide to find what 1 apple cost, and then you times to find what 5 apples would cost. So that would be the more easiest step. So divide first, then you times. So 3. So to get from 3 to 1, you divide by 3. So remember, direct proportion is whatever you do on one side, you have to do the same on the opposite side. So I'm going to have to divide £1.30 by 3, which gives me 0.4333. So I've divided first. And now to get from 1 to 5, you've multiplied by 5. Therefore, the other side, I'm going to multiply by 5. So I'm just going to put that in the calculator. 0.43 times 5 is just 2.17. 2.17. So that's what direct proportion is. Divide on one side, divide on the other side, times on one side, times on the other side. You do the same thing. You, as foundation kid, you do also need to know what the graph looks like. So a direct proportion graph sort of looks like this. So what that basically saying is, as the x-axis increases, the y-axis increases the same amount. So if that is in direct proportion, the amount the x-axis increases, the y-axis will increase the same amount. So if the x is going to be 4, the y is going to be 4. If my x-axis is 2, my y is going to be 2 because it's a straight line going through exactly the middle. So does y-axis by same amount. So in the questions, this is sort of related to graphs. So I've seen a couple of exam questions where they'll give you loads of graphs and they will say, what kind of graph is this? So this is just a direct proportion graph. It's in proportion. The line is going up in proportion to the x and the y. So that's direct. And we will do some exam questions. Direct proportion is sort of like your Best Buy question, your proportion ingredients question. But we also have inverse. Inverse isn't as common. It's more sort of the grade 5, grade 6, but the foundation kids still need to be aware of it. You need to be aware of the graph and what inverse sort of means. So inverse proportion is the opposite of direct proportion. So when one side is multiplied, do the opposite sign on the other side. So for example, if you times on one side, you're going to divide on the other side. If you're going to divide on one side, you're going to times on the other side. So I'll give you an example which will make a bit more sense. So with these kind of questions, it's very hard to tell whether they're inverse or direct proportion. You sort of have to think logically in the question, what would make sense? So the question is, it will take 3 farmers 10 hours to feed the animals. How long will it take 10 farmers? So you sort of have to think, if you have less farmers, so imagine you're on a farm, the less farmers you have, the longer it's going to take to feed like 100 sheep. But if you have more farmers, it's going to take the less, you're going to get it done quicker, so it's going to take less amount of time to feed the sheep. So this is where sort of inverse proportion comes into play. So again, I want to work out how long it's going to take 10 farmers. So I can't go from 3 to 10. So I'm going to go from 3 to 1 farmer first because it's easier to do that. And then from 1 to 10. So 3 to 1, to get from 3 to 1, you divide by 3. But this time on the other side, I'm going to times. But because I divided it by 3 on this side, I'm going to multiply it by 3 on the other side. Because 10 times 3 is 30 hours. Because if you think of it logically, if you have 3 farmers and it takes them 10 hours, if you have just one farmer doing the same amount of job, it's going to take it triple the amount of time. Instead of taking them 10 hours, it's going to take the one person 30 hours. And then to get from 1 to 10, you times by 10, but this time I'm going to divide on the other side. Because if I'm going from one farmer to having 10 farmers doing the same job, it's going to take less time to do. So 30 divided by 10 is just 3 hours. So there's your answer. So that's what inverse comes in. When you times on one side, you divide on the other side. If you divide on one side, you times on the other side. And it's sort of the question is going to be sort of like a logic question where you sort of have to think what would make sense in this scenario. But most likely they will give you a direct proportion question. They're the more best by questions and proportion the ingredients ones. So if I'm looking at the graph, so an inverse proportion graph looks like this. Again, you need to be aware of the graph. That's what inverse graph sort of looks like. So as the y is increasing, the x is decreasing. So if we just look, if my y is going to be 4, then my x is going to be 2. So as y is increasing, the graph is going down, is decreasing. That's what an inverse graph looks like. So be wary of this sort of graph. Okay, so moving on to the exam questions. So question 1, it costs 75 pence to buy 5 bananas. Work out how much it's going to cost to buy 7 bananas. So again, it's always better to write it in ratio form. So if it's going to cost me 75p to buy 5 bananas, how much is it going to cost me to buy 7 bananas? So again, these sort of questions might come up in your calculator and your non-calculator. So the easiest way to do it is, I can't go from 5 to 7 straight away. I'm going to go from 5 to 1. I'm going to work out the cost of 1 banana, then time that to find out the cost of 7 bananas. And this is direct proportion. So 5 bananas to 1, so 5 to 1, I'm going to divide by 5. So I'm going to divide the other side by 5. So 0.75 divided by 5 is just 0.15. And then 1 to 7 is just timesing by 7. So I'm going to time the other side by 7. 0.15 times 7 is just going to be 1.1 pound 5 pence. So to buy 7 bananas, it's going to cost me 1 pound 5 pence using ratios. There are other methods to do it, but the easiest method is, and the most understanding method is the ratio method. So you can visually see what you're timing by, what you're dividing by. Next question. A machine fills 1,000 bottles in 5 hours. Work out how many hours it would take the machine to fill 1,200 bottles. So 1,000 bottles. It takes 5 hours. I want to work out the amount of hours it's going to take to fill 1,200 bottles. So again, I can't go from 1,000 to 1,200. So I'm going to divide it to get 100. And then times it to get 1,200. So 1,000 divided by 10 gives me 100. So I'm going to divide this side by 10. 5 divided by 10 is just going to be 0.5 hours. And then 100 times 12 is 1,200. I'm going to times the other side by 12 as well. So if I just put my calculator, 0.5 times 12 is just 6 hours. Therefore, it's going to take them 6 hours to fill 1,200 bottles. Okay, so moving on. This is where we get to the proportion ingredients questions. And this is sort of using proportion. So here is a list of ingredients for making 10 flapjacks. Work out the amount of each ingredient needed to make 15 flapjacks. So we wanna go from 10 flapjacks to 15 flapjacks. So the easiest way to do it is so 80 grams of oats, 60 grams of butter, 30 ml of golden syrup, and 36 grams of light brown sugar. But we want to get to 15 flapjacks. You can't go from 10 to 15. It's a bit difficult to find out using how much it costs to 10 to find 15. So I would always divide to find out how much ingredients we're going to need to make one flapjack, and then times that amount of ingredient to find out how much it would cost to make 15 flapjacks. So I'm going to divide everything by 10, because 10 divided by 10 is 1. So 80 divided by 10 is 8 grams, 60 divided by 10 is 6 grams, 30 ml divided by 10 is just 3 milliliters, and 36 divided by 10 is 3.6 grams. So to make one flapjack, that's how much I'm going to need. So now I can just times everything by 15. Find out the cost it's going to take me to make 15. So if any of you are considering to do baking in the future, this is what bakers sort of do. If they have a recipe, let's just say, to make 10 cookies and they want to make like 100, they would always scale up their recipe or scale down their recipe. So this is sort of handy when it comes to making produce or baking and stuff. 8 times 15 is 120. 6 times 15 is 90 grams of butter will be needed. 3 times 15 is just 45 ml of golden syrup, and 3.6 times 15 is just 54 grams. So this is the amount of ingredients I will need to make 15 flapjacks. So as long as you do it clearly, you write your answers clearly, the examiner should give you the full mark. So 120 grams, 90 grams, 45 milliliters, and 54 grams. So we'll move on. So these are your best buy questions. So best buy just basically means which is the better value for money. So whenever you go shopping in the supermarket, you'll get like a smaller tub or you get a bigger tub, and you'll always look at which is better value for money to see how much if you're getting the most better price. So I'll sort of go over how you're supposed to approach these questions. So the question says 2 packs of toilet rolls are available in the market. You've got 9 rolls which cost £3.15, and you have 4 rolls which cost £1.36. Work out which pack offers the better value for money. So you want to work out how am I going to get, which one am I going to spend on, so I use my money more wisely. So you've got 9 rolls for £3.15, or you've got 4 rolls for £1.36. So what I'm going to do is I'm going to find out how much I'm going to be spending for each of the offer for 1 roll. So to find out what the offer is costing me for 1 roll, I can see which one is giving me better value for money. So 9 to 1 is divided by 9. So I'm going to do £3.15 divided by 9. 4 to 1 is divided by 4. And then I'm going to divide the side by 4. So this again comes up as direct proportion because you're doing the same on both sides. So £3.15 divided by 9 is just 0.35. So 35p for 1 roll in the first offer is costing me 35p for 1 roll. In the second offer, it is costing me 34p for 1 roll. So you can see the better value for money. For 1 roll, I'm going to be paying less here. So therefore, always write your statement at the end. The 4-roll packet is better value for money, as it is cheaper. So your statement at the end always counts. So you get a mark for that. 3 marks, 1 mark for 2 marks for you working out, and then your last mark is for your statement. So which one is the better value for money? So you can see here for 1 roll, I'm only going to be paying 34p, but for here 1 roll, I'm going to be paying 35p. So moving on to the next question. So 3 packs of tea bags are available in the supermarket. Work out which packet offers the better value for money. So which one are going to be the more feasible to get, which is cheaper. So for which one was better? For this one, the 4-roll, this one was better because for 1 roll I was only paying 34p, whereas the other one it was 35p. So you can see the comparison there. If you divide it to get the same amount. Is that okay, Davin? Yeah, that's fine. So the next question, 3 packs of tea bags are available. Which pack offers a better value for money? So if I'm going to be going in a supermarket, there's 3 packets, but they offer the same thing. Which one am I going to be buying to give me to make my money more useful, to give me the better price? So you can see pack A, 240 tea bags, is costing me £5. Pack B, 200 tea bags, is costing me £4. So for pack C, 160 tea bags is costing me £3. This is why I prefer writing everything in ratio form so I can see it clearly. So so there's 2 ways you can go about this. You'll get the same answer regardless. Either you can get the tea bags amount to be the same, so you can get that amount to be the same, or you can get the pound. So for £1, how many tea bags am I going to be getting? So to make it easier, because to divide 240, 260 is going to be a bit complicated, I'm going to work out how much, for £1, how many tea bags am I going to be getting? So if I just spend £1, how many tea bags do I get? Each of them. So then I can compare. It's basically trying to compare. So 5, I'm going to divide both sides by 5. 240 divided by 5 is just 48 tea bags. Divide both sides by 4. 200 divided by 4 is 50 tea bags. And divide both sides by 3. 160 divided by 3 is 53.3, and so on. So we can see in the first one, if I spend £1, I'm only going to get 48 tea bags. In the second one, if I spend £1, I'm going to be getting 50 tea bags. And the third one, if I spend £1, I'm going to be getting 53.3 tea bags. So really, the better value for money is going to be pack C because I'm getting more tea bags if I'm spending £1. Pack C is better value for money. Because if I spend the same amount in each of the packs, I'm getting the most out of pack C. I'm getting 53 tea bags, whereas the other one I'm only getting 48 and 50. So along with you're doing the comparison, so either you can do the way I did, or you can divide them to get one tea bag, how much are they going to cost? You could do it that way, but that would be because we're working with bigger numbers. It might be a bit more long-winded, but if you've got a calculator, it should be easier. Both ways should give you the same answer. Moving on. So the last question in the ratio. So this is inverse proportion. So it says it takes three painters 6 days to complete a job. So you have to think logically. If you're painting a house, the more painters you have, the quicker the job's going to get done. But if you've got only one person painting your full house, it's going to probably take them 10 days. Whereas if you had 5 painters, it might take them half the amount of time because there's more hands. You have to think logically. What would the answer be? Would it be more people or less people? Work out how many days it would take 2 painters to complete the same job. So again, I'm going to use ratio. So 3 painters takes them 6 days. But I want to find out how long it's going to take 2 painters. So instead of going from 3 to 2, I'm going to go from 3 to 1 painter first. And then 1 painter to 2 painters. So if I have 3 painters taking 6 days, if I divide that by 3, 1 painter is going to take 3 times that amount. So I'm going to multiply by 3. So 6, 12, 18 days. So if the same painter, if it's only one painter doing the same job, it's going to take them 18 days because it's only one set of hands. But now if I have 2 painters doing it, it's going to take them half the amount of time, 9 days. So if you think logically, if you got one painter painting a full house, it's going to take them 18 days. But then if you introduce another painter, they're going to do it in half the amount of time because it's 2 sets of hands now. So therefore, it's going to take the 2 painters 9 days to complete the same job. So hopefully that makes sense, but it's just a bit of logic thinking. But the best buy questions, the proportion ingredients questions, are more to do with direct proportion. The inverse proportion is more like these sort of questions. So that is all of ratio covered. That's everything that foundation students need to know for ratio. Ratio, proportion, direct, inverse, proportional ingredient question, best buy question, they're very common that comes up in the foundation papers all across the exam boards, like OCR, EdExcel. So I forgot to mention, these sort of questions is going to cover all of the exam boards. So I'm not doing it exam board specific because the content is more or less the same in everything. It's just the exam paper is just worded differently. So you still need to know everything. It's just the way the exam paper is written. So now we're going to be moving on to trigonometry. So the second part. So we've got 35 minutes. So trigonometry. A lot of the schools might not have taught you trigonometry yet, because it is more the grade 5 topic. But really, before January, you should have all content covered yourself, even if the school hasn't covered it. So from January to April time, you can just do exam questions because it's the exam question that trips the students up because they can ask it in every sort of format, any sort of format. So you need to be well prepared. As long as you understand what the concept is saying, doing the questions is what is going to help you. So let's go over what trigonometry is. So trigonometry covers Pythagoras' theorem, and SOHCAHTOA. So they're the 2 topics that we're going to be covering. So trigonometry is to do with right angle triangles. So both of them, you have to have a right angle triangle. It just depends. So we'll go over in detail what each of them asks for. So to do it's Pythagoras theorem and to do SOHCAHTOA, it needs to be a right angle triangle. For non-right angle triangle, that's higher. That's when it's the sine rule, the cosine rule comes. So the higher class will be covering that tomorrow. But for foundation, you only need to know about right angle triangles, Pythagoras theorem, and SOHCAHTOA. So let's go over what Pythagoras theorem is and what it's used for. So for Pythagoras theorem, is to find Pythagoras theorem is used to find missing lengths of a side. So it's not to find angles, it's only to find missing lengths, no angles. So you need to be wary of when you need to use it. So if the question is involving a right angle and angles, you know you're not using Pythagoras theorem, you're going to be using SOHCAHTOA. So no angles, and then you will be in Pythagoras theorem to recognize it, you will be given two lengths and you need to find the third length because angle, so the lengths in a triangle, there's three sides in a triangle, three lengths in a triangle. So there's the facts about Pythagoras theorem, when you need to use it and how you use it. So if I just draw a triangle out, there's my right angle triangle. Okay. So let's actually go on what the Pythagoras theorem is. The Pythagoras theorem is a squared plus b squared equals c squared. So what that basically means is that's your length, that's your length, that's your length. The c length is always the longest, so the slanted one, slanted side, or the slanted length. So in this case, the slanted length is this one. So always first label your side C. So C is always going to be your slanted length, and A and B are the other two. It doesn't matter which order. Other side and other side. Doesn't matter about the order. So I'm going to label that as B and that as A. It doesn't matter which side you do it on. You're going to get the same answer. But as long as C is labeled first, C has to be the slanted length. So what that basically saying is to find C, you do A squared plus B squared. So if I just, but I think one thing that kids need to be wary of. So if they're asking you to find C squared, that is just A squared plus B squared. However, they can ask you to find the side A. They will give you C and B and they will say find A. Therefore, A squared is going to be C squared minus B squared. So these are the formulas you need to remember. And if they give you C and A and they tell you to find B, B squared is going to equal C squared minus A squared. So this is your main formula. This is your main one that you need to know. And these are just your rearranged formulas that are handy to know as well, so you're not working it out. So that is everything you need to know for Pythagoras' theorem. Finding missing lengths only has to be a right angled triangle, and you need to be given two lengths to find a third length. You can't do it without only being given one side. You need to have two sides given, and you find the third missing side. So if we just go on the exam questions, it'll make more sense because it's more with Pythagoras theorem, it's more practice. So first question here, speed up a bit, we've got half an hour left. So question one says, calculate the length of AC. So can you see how in the question they've not told you whether it's to do with Pythagoras, to do with SOHCAHTOA, so they don't explicitly tell you the question of what you need to use. You need to decipher that yourself. So I can see it's a right angle triangle. We're finding the length of A to C. So we're finding a length. So again, that's what we need to do for Pythagoras. And we've been given two lengths already. So we've given that ticks the box of you were using Pythagoras. So I'm just going to write the equation down on the side so I can see it. So the first step is label your triangle. So remember what I said, labeling C first. The C is always a slanted side, so I'm going to label that C. And A and B, it doesn't matter which side you do, so I'm just going to label that A and B. So in this case, we've been given B, we've been given the length of A, but we need to find C. So C squared is just going to be A squared plus B squared. So we're just going to sub everything in. So squeeze C squared is going to be A squared. So A is 5.6, 5.6 squared plus B squared, which is just going to be 4.2 squared. If it's these are more likely going to come up in the non-calculator, sorry, the calculator paper. But if it's a non-calculator paper, they'll give you more manageable numbers that you can actually work out, like whole numbers. They won't give you decimals because they understand that in a non-calculator you won't be able to do that. So therefore, C squared is going to be, I'm going to work out what 5.6 squared is on my calculator. 5.6 squared is just 31.36. And I'm going to work out what 4.2 squared is. It's just 17.64. So I've got that, so I can add them up, I can simplify it. 17.64 plus 31.36 is just 49. So I can see C squared is 49, but that's not my final answer because I need to find C, but that's C squared. So to get rid of the squared, you have to square root the other side. So kids always miss out the last step. So remember, your answer is not C squared, it needs to be C. To get rid of the squared on the C, you square root the other side. So we know square root of 49 is just two numbers that time together to make 49, which is 7. Therefore, length of C is going to be 7, and make sure you write the units centimeters, which makes sense. If you get something like really big, like 105, you know it doesn't make sense because how can that length be 4.2, that be 5.6, and the other one be like a really big number, a really small decimal? The sort of thing, does my answer make sense as well? And there's the first one. We'll move on to the second question. So again, same thing, same concept. Question says calculate the length of AB. So it's asking us to find the length. It's a right angle triangle and we've been given two lengths. So I know it's going to be Pythagoras. It's not going to be, if there's no angles involved, we're not finding any missing angles. It's not giving us any angles. Therefore, it cannot be SOHCAHTOA. It has to be Pythagoras. So let's just highlight what it's asking us. Calculate the length of AB. AB is this length here. So first of all, let's write down what Pythagoras' theorem is. So always write it down because sometimes if it's like a big, really high marked question, they might give you a mark, but just write it down what Pythagoras' theorem is. So always write it down. A squared plus B squared is C squared. So let's label it. My slanted side is this one. This is my slanted side. Therefore, that has to be C. And then A and B doesn't matter. So I'm going to label that as A and I'm going to label that as B. So now we've been given C and we've been given A, but we haven't been given B. So we need to find B. So this is why I wrote down the rearranged formula. So we need to find B. So we're going to be using this one here, this formula. B squared equals C squared minus A squared. So I'm just going to rearrange that. B squared equals C squared minus A squared. So I'm using that formula because wherever you're finding is always the subject. So if I just put it into the formula, I just sub everything in. B squared is what we're finding. C squared is 17.55 squared minus A squared, which is just 6.75 squared. I just worked that out. 17.55 squared minus 6.75 squared is just going to be, I just sub that in my calculator, it gives me 262.44. I just put that straight in my calculator. Now remember, your answer is not B squared, it has to be B. So I need to square root this side. You always square root at the end. So remember, with Pythagoras, you always square root because these are squares. You don't want them to be squared, you want them to be just original. So square root the other side, so square root of 262.44 is just 16.2. Units are centimeters, which makes sense. If that's 6.75, that's 17.55, that makes sense. It's going to be 16.2. So that's how you do Pythagoras' theorem. Identify your triangle, label your triangle, write down the equation, rearrange the equation if needed, Sub everything in and square root at the end. Just a couple of steps you need to remember, and it's the same for every question. So now let's move on to SOHCAHTOA. The SOHCAHTOA is the more harder one. It's a lot more steps involved. So SOHCAHTOA will go through the meaning of each of them, why it's called SOHCAHTOA, what each of them mean. So with SOHCAHTOA, so Pythagoras with only length, so SOHCAHTOA is used to find missing lengths and missing angles. So this time is to do with angles as well. You find missing lengths and missing angles. So either you're going to be given two lengths and find the angle, or they will be given one angle, one length to find the missing side. So it just depends what's given, but it's involving angles and lengths. So and it has to be a right angle triangle again. The non-right angle triangle is the highest stuff. So let me just write down. It has to be a right angle triangle. There you go. So that's when SOHCAHTOA is used. Now let's go through what a SOHCAHTOA actually means. So in SOHCAHTOA, so if I just draw a triangle, it'll make more sense. If you have a right angle triangle, and let me just draw an angle given, say the angle X degrees. So instead of labeling it in Pythagoras, we labeled it A, B, and C. With SOHCAHTOA, there's three names that we label a triangle with. The longest side, so the slanted side, is always called the hypotenuse. So the longest side is always called the hypotenuse. Remember that. The side opposite, in a darker color, the side which is opposite the angle given, not the right angle, the angle that's given to you or that's drawn, is called the opposite side. So opposite side is called that because it's opposite the angle given to you, not the right angle, the opposite given to you, the side given to you. And then the remaining side is called adjacent. It's called the adjacent side. So we have hypotenuse, opposite, and adjacent. So always label your hypotenuse first, then label your opposite side, and then label your adjacent side. So instead of A, B, and C, we have hypotenuse, opposite, adjacent. So the H is hypotenuse, O is opposite, A is adjacent, H is for hypotenuse, O is for opposite, and A is for adjacent. And these are just sine, cos, and tan. You'll have them on your calculator as well. Sine, cos, and tan. That's what we have. And one thing to remember is if you press shift and sine, you'll get something that looks like that. I don't know if you can see it. Sine -1, which is the inverse of sine, which we will be covering what that is used for. So sine, cos, and tan on your calculator, that's what we're going to be using. Okay, so there's a couple of things you need to remember. Let me just draw the triangle, that will make more sense. So how I like to do it is, I like drawing them in triangles so you know when to rearrange, because either what if the angle is given and the opposite is given, so you need to find the hypotenuse. So a triangle makes it more easier to rearrange. So let me draw the three triangles. I have got a document which has all of these on there, so we will be sending you that out as well. Let me do it a bit smaller. Just like you have a triangle for speed, density, and time, or any sort of triangles, we're using triangle in this case as well. Remember, this line means multiply, and the top line means divide. So with the first one, sine of x equals opposite divided by hypotenuse. So I'll go through all of these again. Cos of x equals adjacent divided by hypotenuse, and then tan of x equals opposite divided by adjacent. So let's go through each of them, what each of them mean. Sine of x equals opposite divided by hypotenuse. So this x is your angle. So your angle goes with your trig functions. So whatever angle that's given in the triangle, not the right angle, the angle that's given. So whether it's 50 degrees, 40 degrees, we're going to write sine of 50 equals opposite divided by hypotenuse. So sometimes you might have to rearrange. That's why the triangle comes into play. What if they tell you to find the hypotenuse? So we know hypotenuse is going to be opposite divided by sine of x. That's why I prefer using the triangle to rearrange the questions. And remember the x is always the angle. Second one, cos of x equals adjacent divided by hypotenuse, and there's your angle. And tan of x equals opposite divided by adjacent, and there's your angle. They might ask you for, in the question, find the opposite. Opposite equals, in this case, sorry, they might tell you to find adjacent. Adjacent equals cos of x times h. So another thing to cover, how do you know when to use cos, sine, and adjacent, cos, sine, and tan, sorry. In the question, you have to look at what's given to you. If the question, if in the question you've been given, when you label it, so that's why labeling is important. If you've been given opposite in the question and you need to find hypotenuse, you're going to be using sine of x. If you've been given hypotenuse and adjacent, so h and a, or you need to find h and a, you're going to use cos. If you've been given, if the triangle involves O and A, you're going to be using tan. So in the questions, it'll make more sense when we do them. Okay, the inverse. So let me just tell you how you use the inverse trig function. That's something to know as well. So inverse trig. If you've got a question, if you put it in the chat, we'll be able to answer it. Just type your question in the chat. Inverse function, so these are to find missing lengths. So the inverse function, inverse trig function is to find the missing angle. So it's when you do sine of -1, so and so equal x equals, so your angle, which is x equals sine of -1. And how you get the trig function, you do shift in your calculator plus your trig function. Shift plus trig gives you your inverse function, and they're to find your missing angles. So inverse trig to find the missing angles, the normal trig function to find the sides. So I know it's a lot of information to know about SOHCAHTOA, not SOHCAHTOA, yeah, SOHCAHTOA, sorry. But the question that make more sense. I'll move on to the questions. So let's go through how you're supposed to answer them. So be given a triangle. First of all, it's a right angle triangle. So yes, I'm going to be using either SOHCAHTOA or Pythagoras. So this is where you need to decide on what you're using. It's given us an angle and it's given us two sides. We've been one side to find and one side that's given to us. Therefore, it cannot be Pythagoras because it's given us an angle. So it's going to be SOHCAHTOA. I'm going to just write it on the side. So before anything else, we need to label the diagram. So labeling it helps us determine if we're using sine, if we're using cos, if we're using tan. So I'm going to label it. The longest side is always the hypotenuse. So there's the longest side. That's going to be the opposite side. And there's my adjacent. So we've been given adjacent, so the adjacent length given to us. We need to find the opposite, and we've been given an angle. So hypotenuse, we don't need to worry about hypotenuse. I can rub that out. We don't need to do anything with hypotenuse. Actually, let me just write that down. So we don't need to worry about that. So there will always be between adjacent, opposite, and hypotenuse. One of them you don't need to worry about. So so we need to find out which of these trig functions has an a and has an o in it together. A and the o is a tan. So tan of x equals opposite divided by adjacent. So we have o and a here. Therefore, we're going to be using the tan function. So always look at which one has the two letters that you need to use, and then from there you can determine whether it's sine, cos, and tan. So we're going to be using tan, so we're going to sub everything in. So subbing everything in, remember there your angle goes there. So tan times the angle that's given, which is 42. Tan times 42 equals the opposite side, which is x, which we need to find, divided by the adjacent side, which is 11. So this is why I said using the triangles will be important, because we need to find the opposite. So if I just go here, so in the tan, to find the opposite, what I'll have to do is I have to draw it on the side. To find the opposite just means tan of x tan by my adjacent. So I'm going to rearrange it. Therefore, my opposite side, so my x side, is going to be tan of 42, right, 2 properly, times by my 11 centimeters. This is why the triangles are important, so you can always rearrange, because it can get a bit confusing, but the triangles make it visually, you can see where do I need to rearrange. What if we need to find adjacent side? So adjacent is going to be opposite divided by my tan of x. So triangle is important. So now I can just put that in the calculator. Tan, so tan of 42 tan by 11, and the answer is 9.90444. I'm going to give it to one decimal place. So x is going to be 9.9 centimeters, which makes sense. 9.9. So with Sokotowa, label your triangle. First label it. See what's given to you, what's not given to you. Determine whether you're using sine, cos, or tan. Draw the triangle. Rearrange if you need to have to, and then just solve it. So this is how a straightforward Sokotowa question would be. It's a very typical one that I've seen quite a few times. It always comes up in either, most likely it comes up in a paper 3, I think, a calculator paper. The non-calculator paper, I will show you when we use how we use Sokotowa for non-calculator. How many questions are there? Just 2 more, and then we need to go over the exact trig values. So let's look at this question. Let's approach it the same way I did. So I'm just gonna write Sokotowa on top. You can see. So let's label it first. So my longest side is hypotenuse, right, H. That's my opposite, and then that's my adjacent. We need to find H. We've been given O, we don't need to do A. So we need to find which trig function between sine, cos, and tan has O and H. I can see O and H is sine, because sine of x equals opposite divided by hypotenuse. So that has O and H in it, so we're going to be using the sine trig function. I'm just going to draw the triangle on the side in case I need to rearrange. Say over hypotenuse. So let's see what we need to find. So we need to find hypotenuse. So this is, we don't know, we need to find hypotenuse. Therefore, hypotenuse is the opposite divided by, so the opposite side, write it down, divided by sine of x. So as everyone understood why I rearranged it, because I'm trying to find hypotenuse. Whatever you're finding is the subject. So now I can just sub everything in. H equals opposite is 20. That's given to us. Divided by sine of the angle is given to us 35. I just need to sub that in the calculator. That gives me 34.9 to one decimal place. So finding the lengths, and so this question was finding the length. This question was also finding the missing length. So that's straightforward. You just do what was given, what I've done in the question. So finding an angle is a bit more trickier. This is where the inverse trig function comes. It's the same method. It's just there's an extra step at the end. So this question here. Calculate the size of angle ACB. So just by looking at this, you might think, okay, I'm using Pythagoras because two lengths are given to us, but it's actually asking you to find the angle. So we need to find angle ACB. A fact is when the notation of an angle is given at 3 letters, the angle is always in the middle. So we are gonna have to find angle C. So ACB angle is gonna be C. So we're given two sides and we need to find angle. So again, because it's involving angle, it's a right angle triangle, it's going to be a SOHCAHTOA. So next step is let's label. This is the longest side is hypotenuse, which is here. That is my opposite side. And there's my adjacent. We've been given hypotenuse, we've been given opposite. We don't need to worry about adjacent because that's got nothing to do with it. You're only ever using two sides at once. Okay? So now let me just draw the triangle. Which one has O and H in it? Sine. So sine of x equals opposite divided by hypotenuse. I'm going to draw the triangle. Opposite divided by hypotenuse. And this time we need to find the angle. So sine of x is going to be the opposite side. Opposite side is 5. Make sure you're writing them in the right order. So the opposite divided by the hypotenuse, which is 16. So 5 divided by 16. A lot of kids end up writing 16 divided by 5, but it's not. It's O divided by the H. The length of O divided by the length of H. So just looking at that straightforward, finding the angle, there's nothing else we can do here. So this is where the inverse function comes in. So what that essentially means is to find x, we need to move the sine part on the other side. And this is where we do the inverse. Therefore, the x is going to equal the inverse of sine, the sine of -1, and then we're going to time that by 5/16. So in your calculator, if you press shift and sign, that gives me sine of -1, and it'll give you an open bracket. In the bracket, I'm just going to write 5 divided by 16, and that should give me my answer. X equals 18.2 to 1 decimal place. If the question doesn't tell you to give it to 1 dp, 2 dp, always give it to 1 decimal place on the B on the safe side, 18.2. So this is where to find angles, you use the inverse function. So that is trigonometry simplified. There's one more thing, we've got 5 more minutes, what we need to cover. So more or less, mostly these questions will be in the calculator paper. So you will have a calculator to do all these. But a few times they'll trick you up and they might put these questions in the non-calculator paper. So this is where you need to know your exact trig value. So it's a small topic. So we call this exact trig value. So it's something you have to memorize these values. And I'll show you what I mean. So in schools, what they'll normally do is they'll say, this table you have to memorize. You might have seen it in the school, you might not have seen it. So they'll just say, memorize this table. But memorizing it can be quite tricky because how are you supposed to remember each of them? It's quite tricky to remember. So there is a way which I'm going to show you how you can derive this table. It takes probably like a minute to write, and then from there you can derive each of them. But usually it's this table you have to memorize exact trig values. So let me just show you how to do it. So I'm going to try go over it as slow as possible because it can be quite confusing. So you need to draw this table. So draw a big square root. Draw a big square root you're going to draw. And on the side, you're going to write sine and cos in this order: sine on top, cos on the bottom, on the left-hand side of the square root. And on top, you're going to write 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. It's always that. So you draw this first: 0, 30, 45, 60. If I just like that. And it's all of it is going to be divided by 2. So this is what you need to draw. Memorize how to draw this. Draw the square root 0, 30, 45, 60, 90, and then sine and cos on the left-hand side, and all of it is divided by 2. And how you memorize it is, you're going to write 0, 1, 2, 3, 4, and then for cos it's backwards 4, 3, 2, 1, 0. So once you've drawn this, we can sort of know what each of the exact trig values are. So you can work it out from this table. And so this table is only for sine and cos. For tan, you can then it makes it easy just to memorize. Tan is 0. Tan 0 degrees is just 0. Tan 30 degrees is 1 over root 3. Tan 45 is 1. Tan 60 is root 3. And then tan 90 is underdefined, so you don't have that. So this is for sine and cos. So let's do an example, question 1. If the exam question asked you, tell me what sine 45 is. So another thing to remember is, in the non-calculator paper, they will only ever give you these degrees. They won't ever give you like sine 35 or sine 95 or sine 67. They won't ever give you random. They'll only ever give you them degrees to do. That's why that's the only one you can memorize. So let's just say in an example, you have to find out what sine 45 is. So let's use this table. So sine 45. So if I just read the table of sine 45 is just, remember it's a big square root of 2 divided by 2. So there's your answer. Sine 45 is square root of 2 over 2. Foundation kids can leave it like this. Higher kids have to solve this, so rationalizing the denominator. That's a topic in higher. So higher kids will then go on to know how to simplify this even more. But foundation kids, you need to know sine 45 is root 2 over 2. You don't need to do anything to it. So that's your final answer. So sine 45, reading it off to root 2 over 2. Let's do another one. Let's work out what sine 90 is. So sine 90 is square root of 4, all divided by 2. So remember, it's always divided by 2. We know what square root of 4 is. Square root of 4 is just 2 divided by 2, which is just 1. So sine 90 is just 1. Let's do another one. Cos 60. Let's work out what cos 60 is. So cos 60, I'm looking at the cos row. Cos under 60 is square root of 1 divided by 2. You can't do anything with that. So cos 60 is just square root of 1 over 2. Square root of 1 is just 1. So 1 over 2. So we're left with 1 over 2. Let's do another one. Let's work out cos of 0. These are all the degrees, by the way. Cos of 0 degrees. Cos of 0 is just square root of 4 divided by 2. We know square root of 4 is just 2 over 2, which is just 1. So cos 0 is just 1. So this table can be used to derive all of them. Just remember that the numerator is under the square root, and the denominator is always divided by 2, and then you can simplify them. If you obviously don't want to use this method, you can always memorize this table, but just to double check your answer, you don't want to lose like a mark or two just because you don't remember. It's always handy to know this table, and then from this table you can always double check what your answer is going to be. Okay, so that is, let me just double check that's all the questions done. Yeah, that is all the questions done. So that is just in time, it's 2:30. So what I'll do is I will save this, get this emailed out to you, get the recording emailed out to you, so you can have a copy. So we covered all of ratio, direct and inverse proportion, and all of trig for foundation level. So high level class is going to be tomorrow, which will be building up further on this. So hope if you've got any questions, do you want to add them in the chat? But if not, then I'll end the session here. I hope you benefit from that and you learn something. You might not have come across these sort of topics in school yet, but ideally you need to have seen these. So the December holidays, use these holidays to get familiar with everything, familiar with all the topics, because the grade 4, grade 5 topics are the ones that the kids tend to miss, but they're the question that are going to get you the grade 4 and grade 5, which is what you need to pass. So if you've not got any questions, I'll end the session there and I'll get everything emailed out to you. So you've got a copy of the answers and you've got a copy of all the notes. And then you've got, if you want to refer back to the meeting, I will send you a link to the meeting recording as well, so you can watch that back, just in case if you missed anything or you felt like I might have gone a bit too fast. You can re-watch it and see how I got the answers. Right, see you guys.